So, as usual, the first thing we need to do is to read the question, identify the key areas and things to concentrate on. So, sketch the graph of a is greater than 0, so it's a positive number, and x is greater than negative a, labelling any asymptotes and points of intersection with the x-axis or y-axis. Leave your answer in terms of a where necessary. So, as usual, I like to start these just by building things up from what we do know. So, I'm going to do a little sketch to start with of log x, the base 9. The base doesn't really matter as long as it's greater than 1. So we know that the log graph has that kind of shape to it. Got a little tail on there, which I don't want. Oh dear, let's try again. But it's that kind of shape, increasing. Okay, so now we know that f of x mapped onto f of x plus a is a translation, and this is learning, and it's going to move the graph in the x direction because it's inside the bracket, so it's negative a 0. So I'm talking about that plus a, x plus a is inside the bracket. It's inside the function, so you move it sideways before you give it its shape in effect. So we now know that we've got a graph which looks that shape, and we've moved it back a. So this line here is x equals negative a. This is our graph y equals log to the base 9 of x plus a. Here's our x-axis, here's our y-axis, and here's our origin. So that's actually our answer. But we've also got to label the asymptotes, labelling any asymptotes, which we've done, x equals minus a. This graph I should have been more careful about here. This line must, the asymptote slash axes must be drawn with a ruler. Yeah, they must be straight lines. Okay, and any points of intersection. So we've got 2 points of intersection. 1, 2. So those occur when at x equals 0, y is equal to log to the base 9 of 0 plus a. So that's going to be log to the base 9 of a. So that's that point there, log to the base 9 of a. Secondly, we want y equals to 0. So that's where it crosses the x-axis. So 0 equals log to the base 9 of x plus a. Take off the log. So to what power must 9 be raised to get x plus a? So 9 to the 0 equals x plus a. Anything to the power 0 is 1. So we take away the a. So we've got minus a plus 1 equals x. So we can label this point in here, negative a plus 1. And that is it. It doesn't say give you coordinates or anything like that. It just says labelling them on the graph. Okay, part B. For x greater than negative a, describe with a reason the relationship between the graphs of log to the base 9 of x plus a squared and log to the base 9 of x plus a. So part B, we don't know what the squaring does. It's not one of our standard functions. I'm talking about this bit here. Yeah, we don't know what maps f of x onto f of x squared does. Yeah, this isn't one of our standard results. F of x going on to f of x squared. So what can we do? Well, we're working with logs, and we should have learnt log to the base a to the n equals n log a. So we can write y equals log to the x plus a squared is equal to 2 log of x plus a. Now that should look more familiar to us in terms of our transformation of graphs. So we know f of x is mapped onto a f of x by a stretch scale factor a in the y direction, or we could say x-axis invariant is actually a better way of saying it. Okay, so it's stretching it away from the x-axis. So, what was the actual question? Describe with a reason the relationship between the graphs of. So, we now just need to put that into words. I would tend to write log of x plus a is mapped onto log of x plus a squared by a stretch scale factor 2 x-axis invariant. You don't have to give these answers in sentences. Clear mathematical descriptions, notation is completely acceptable.